everyone, and welcome to these exponents lessons. And in this lesson we are simply looking at the introduction to all the exponential definitions. Now the exponential definitions can change the way the expression looks. Okay, so it changes the way a sum looks. From there we can apply the laws according to Botmas. Now I also want to tell you that we can always apply the laws according to Botmas, and then we can also use definitions to change the way my answer in the end looks. So vice versa, we either can use these definitions in the beginning and then follow Botmas, or we can follow Botmas and then do the definitions in the end. Okay, so any base to the power of 0 makes that base equal to 1. Now, very important. If a base has a power of 0, it makes that base equal to 1. So this answer will be a 1. Now let's look at another example. Let's say I have 2 to the power of 0. That answer becomes a 1. Okay, so any base to the power of 0 is 1. Now what if I write a and then I write a to the power of 0 and I write b? What will be the answer? Now what's very important to understand here is that it's only the a, only this base that has a power of 0. So only this a, and I'm going to circle it in purple for you, so only this base has a power of 0. This b still has a power of 1, right? So only the base that has a power of 0 becomes a 1. So basically in the place of a to the power of 0, we put a 1, and then we still have the b. And that gives us 1 times b equals b, right? Okay, so don't forget it's only the base to the power of 0 that becomes a 1. Now, our next definition. 1 to the power of any exponent remains a 1. So 1 to the power of a, well, it stays a, because a can be any exponent. Now let's look at another example. A to the power of, let's say 21, that is still equal to 1. Okay, so 1 to the power of anything remains a 1. Now, how about the third definition? When a fraction is in brackets and it gets raised to a negative exponent, now there's the fraction in brackets and it gets raised to a negative exponent, then we can simply swap the fraction around and change the exponent to a positive. So let's see what happens. This is the fraction on the inside, it gets raised to a negative exponent. So what we basically can do is, we can just say now it will be b over a. See how I swap this fraction around? Okay, and we leave it in brackets, and then basically that negative exponent on the outside becomes a positive exponent. Okay, great. So that is easy enough to understand, right? So when we have a fraction inside brackets and it gets raised to a negative exponent, we simply swap this fraction around and that negative exponent becomes positive. So let's have a look at another example, a real example with some numbers. So if we say that this is, for example, 2 over 3 to the power of negative 2, this will simply be 3 over 2 to the power of 2, and then we can continue to apply one of our laws of exponents, which means that this is the 3 to the power of 2 and 2 to the power of 2, which will be 9 over 4. Okay, so that is quite easy to understand, that if we have a fraction inside brackets, it gets raised to a negative exponent, we swap the fraction around and that negative exponent becomes a positive one, and then we simply do our law, which says that it will be that numerator to the power of 2 and the denominator to the power of 2. Okay, great. So let's go and look at our fourth definition, which is quite a long one. Now this definition simply states that when a base has a negative exponent, we remove that base with its exponent. Okay, so it's only the base that has a negative exponent, we remove it and place it on the opposite side of the fraction line. And then that negative exponent becomes a positive exponent. So let's quickly see what happens. So this is the base is a and it has a negative exponent. So if we write this as a fraction, and you don't need to do this, but you need to know it, that if we write anything on top of a 1, it still remains an a to the power of negative n. So whether we write this purple line with the 1, it is there whether we see it or not, right? So I'm just going to take this a, which is the base that has a negative exponent, and I am going to pluck it out there, okay? So I'm not going to swap this around. I'm simply going to lift it up and put it below this line. So now I have to actually create this line, and I'm going to take the a, put it below the line because that is the base with a negative exponent. And why do we do this? To get rid of the negative exponent. So it will just be a positive n. And then we cannot say that nothing remains at the top because the coefficient in front of the a is still a 1, right? So that will be 1 over a to the power of n. Please, no, it's not a swap around. It's basically I pluck this from there and I go place it below the line. So let's have a look at an example with some numbers. Let's say I write here 3 to the power of negative 2. Now, this simply also means the same as 3 over 1. Okay, so it will be 3 to the power of negative 2 over 1. Now, any base that has a negative exponent is actually a fraction. That's why that becomes this. So to help us, this 3 to the power of negative 2, we just put it over 1, so it still stays 3 to the power of negative 2. And then which base has a negative exponent? It's only the 3 that has the negative exponent. So we pluck this entire base with its exponent. We pluck it from there where it is the numerator, and we go place it below the line where it becomes the denominator, and the negative exponent becomes a positive 2. And what remains at the top? Still a 1. And this gives us 1 over 9. Okay, so any base that has a negative exponent is actually a fraction. So please don't forget that. And it works the other way around as well, as you will see later. So let's go to the next example here. Here we have a times x to the power of negative n. Which base has a negative exponent, the a or the x? Well, you are right, it's the x, right? So this one, I need to pluck that one out because we don't want the negative exponent. So this means that all of this was over 1. So now I'm simply removing this x to the power of negative n and go put it below the line. So if I draw this fraction line there, the a stays at the top. You're following me, right? And then the x goes at the bottom, but the negative n becomes a positive n. And there we go. So quite easy. How about if we use some numbers and letters? So let's write here 2, and we have a to the power of negative 2. And this will equal 2. Now again, the 2 is a base. The a is also a base. This is 2 to the power of 1, which is positive. That one stays there. This is a to the power of negative 2. So that entire base with its exponent, which I will circle now in purple, that one does not belong at the top. It needs to go to the bottom because it has a negative exponent. So basically I can draw the line. The 2 stays at the top. And the a to the power of negative 2 becomes a to the power of 2 at the bottom. See, I simply pluck it and go put it below the line. It's not a swap around. So please remember that. And if you're unsure, do you see any fraction lines? No. So it means to keep it the same, we can put it over 1. And that means that one and that one is at the top, but that one does not belong at the top because it's got a negative exponent, needs to go to the bottom. Okay, great. So, let's look at the third example. A times x in brackets to the power of negative n. Well, this is an interesting one because everything in these brackets belong to that negative exponent. It's not just the x and not just the a. It's both of them because everything in the brackets belongs to the negative exponent. Okay, that's why we put it in brackets. So that means if we want to keep this the same, we can also write it as a times x in brackets to the power of negative n over 1. And now everything at the top is to the power of negative n. So everything there needs to get plucked out and put below the line. So let's quickly draw that fraction line here. So this becomes a x in brackets to the power of positive n. And what remains at the top? Because at the front of this bracket there's a 1. And there we go. Now, some of you will wonder what happened to this purple one. Well, 1 times anything stays anything, right? And I just introduced that just to show you that the fraction line is actually below this base to the power of negative n. Because if we put it on 1, it still remains exactly the original. But now, because it has a negative exponent, we pluck that entire base with its negative exponent and we go put it below the line, easy to see, and then what remains at the top? We cannot say nothing, a 1 remains. Now, how about our next example? In this one, or let's just go back to this one and quickly just do a number example here. So this will basically be 2, let's make it 2a to the power of negative 2. Okay, so let's see what happens. To keep this the same, I can also write it as 2a in brackets to the power of negative 2 over 1, right? Okay, so now everything in the brackets belong to that negative 2. So I simply have to take all of this and put it below the fraction line. So let's go and do that. And remember, if we take everything at the top, only a 1 remains. And then at the bottom, we will have a 2a to the power of 2. But now we're not done, because we can use one of our exponent laws. Because when we have things in brackets to the power of a positive exponent, simply means it's that exponent 1. And I'll do that in purple, that 1. And then I'll show you in green, 1 times 2. So this will become 2 to the power of 2. And then we will have a. And that a also has a power of 1. Times 2, so it will become a to the power of 2, and this will be 4a to the power of 2. Well, I always skip the part where I have to multiply that integers exponent with the exponent on the outside. I just simply say integers to the power of 2 will give me another bigger integer, right? So 2 to the power of 2 gives me 4. So you don't have to put in that step there if you want to work a little bit faster. So that is it. It's quite easy. So just remember that we don't really want to work with negative exponents. Well, you can multiply in like this, and then you have to swap both around, and then you will end up with that, which ends up with the same answer. Because like I said in the beginning, we can use these definitions right at the beginning, or we can do BODMAS and then with our final answer apply the definition, because we never want to end up with negative exponents. So, how about this example? Now here we've got 1 over a to the power of negative n. Which base has a negative exponent? Well, it's this a. So, this one has a negative exponent. So, we already have the fraction line there. So, where must this one go? Now it's at the bottom. If we want to change that negative exponent to positive, it needs to go to the top. So, this will become a to the power of n. And remember, what remains at the bottom? Not a nothing, it's a 1, because if we write a 0, anything divided by 0, well, we basically can't divide by 0. Okay, so if we take everything, a 1 remains, and anything over 1 is just the numerator, so it will just be a to the power of n. Okay, so it will be a to the power of a positive n. That's why we moved it. And now, how about a normal example? So if I take, for example, 2 to the power of negative 2, I put it below 1. So I make the 2 to the power of negative 2 the denominator. Now it doesn't belong there anymore because we don't want to work with negative exponents. So we take this entire base that has the negative exponent and we go put it on the opposite side of the fraction line. So it will be a 2 to the power of a positive 2 over 1. And that just basically gives me a 4, because 2 to the power of 2 is 4 and 4 over 1 is a 4. Okay, easy enough, isn't it? So I hope you can follow. Now, how about this one? Similar to this example here, the only difference is now the ax to the power of negative n is below the line. So everything in the brackets has a negative exponent, so it needs to go to the top. And I'm just going to go a bit faster because you can always re-watch this part. And it will be a times x in brackets to the power of a positive n over 1, which just simply gives us ax in brackets to the power of n, which then will become a n x n, right? And we can simply do it there too, which will be 1 over a to the power of n and x to the power of n as well, because 1 times n is n and 1 times n is n. Okay, so you know this. How about the next example? Now, this is a tricky one, and many learners forget about this. So please remember that it's only the base that has a negative exponent that gets moved. So it goes to the top there, and the a remains at the bottom, and I am done. Okay, so how about a practical example? So 1 over 2a to the power of negative 2, this simply becomes, we only take that base that has the negative exponent, it goes to the top, the exponent becomes positive, and the 2 remains at the bottom. Okay, great. And what about the 1? Because 1 times a to the power of 2 is a to the power of 2. That's why I don't write the 1. Okay, so how about this? Well, that one's got a negative exponent, so it needs to move to the top. So it will just simply become a. We put the x at the top next to it, to the power of n. What remains at the bottom of 1, so it will just be ax to the power of n. And we don't have to write the step. I'm just showing you this one, that a 1 remains at the bottom, and anything over 1 is anything. You remember that from your fractions from a long time ago, right? Now, how about this example? A to the power of negative m. So this has got a negative exponent, and this one has a negative exponent. So the a needs to go to the bottom, and the m becomes positive. The b needs to go to the top. So let's write that at the top, and the n becomes a positive one. So look, it's just simply this one goes to the top, that one goes to the bottom, and the exponents become positive. Okay, so please remember, for these definitions, all of these on this page, you have to remember we only move the base that has a negative exponent to either above the fraction line or below it, because we do not want to work with negative exponents. And my last little hint is, for all of the definitions we learned in this lesson, you can apply them right in the beginning, or you can do BODMAS, and when you get to your final answer, you apply the definitions. For example, you get to a final answer that looks like, for example, like this. We have 4a b to the power of negative 2. We cannot leave it like this because we don't want negative exponents. So we have to rewrite it as 4a. And then remember, we take this b to the power of negative 2, it goes to the bottom, and the negative 2 becomes positive. So that's how we can apply the definitions. So great work through this lesson. Don't forget these definitions because they are very important. I hope to see you again soon. Bye. This is your host, Richard T, and thank you for joining us. Please visit our website, mathsa.co.za, for free guided exam tutorials.